Hello, and welcome to this episode 3 of Poor Man's Electronics Bench. In this episode, I am going to try to restore a capacitor substitution box or a capacitor decade box I purchased on eBay to a functional condition. This little gem I picked up, it wasn't very expensive. It's a seems to be a fairly functional unit as far as having a large selection of values at a high enough voltage to do tube radio and amplifier work and some general work on a lot of components. Just they have access to something that you can put a switchable value and use fairly easily is nice, and I figured this would be a good item to look at. I purchased it, and after getting it home, it shipped intact with no damage, but I was hoping for a little bit better result on the inside of it, but after opening it up, I came to the conclusion that it's going to be a lot more work than I thought to get this unit functional. I was not planning on using or reusing any capacitors that were originally installed. There's a bunch of old dynamite sticks that are well past their functionality. I'm sure they're all leaky and not going to be good items to use. I was hoping that the mechanical parts as far as switches would be in a little better shape, but coming to examine them, I found that I've got some issues going on. I've got the one particular contact on the switch is not going to be usable. It is this one right here. It ends up that I can take this contact. I was hoping to be able to get in with a good cleaner and swab all of these and get all the corrosion off it. But in this case, this one contact here bends up so far that it's got basically no spring to it as far as making contact with the rotary wafer part, and I am at the point where I'm not going to expend any time in trying to recover this switch. If I had more of these switches and more parts, a little rivet, some time, and a lot of inclination and craftiness, I might be able to replace that one contact. But in general, I can probably find a switch that has a similar amount of contacts, do a little rewiring. This has some functionality as far as discharging either the capacitor inside the device or capacitor under substitution or test through a 500 ohm resistor, and it's hooked up through this switch here. I'm not sure if this switch can be salvaged. I'm going to have to disassemble it and take a look at it as well. It's probably going to entail me replacing the rotary switch, possibly this switch, and a total rewire. And I do have a selection of capacitors at the rated voltage that should all fit in this box to be wired into the switch. The box itself is only maybe about 5 by 5. I want to say in close to 2 inches in depth. So it's not really huge. But going forward, I would like to make this a functional unit so I can have one item on the bench to use quickly. Like I said, not fumble around, look through a stock of capacitors, or when I get handy and have to worry about soldering it into place or something, I can just clip it on, go for it and test. Or to get something working in lieu of having, like I said, having to tack solder something in to get it going. So we're going to hope that this device will cooperate and be useful for my needs. For curiosity's sake, I am going to take one of these fine capacitors out and just do a test on them and see how bad they are, just for a laugh. I mean, it's going to be it's going to be bad. I can imagine this whole bottom part of the box is filled with some sort of looks like a salt almost that's leaked out of these capacitors. It's just nothing I'm going to want to deal with. I'm not even going to worry about a schematic on this because it's going to pretty well be a total rewire of the new switch. So we're going to go through it and clip out one of these guys, get some enough insulation on the leads so I can do a test on them. They've got the I don't think they're in any shape of holding residual charge from the last time they were used, so I'm not going to worry about discharging them in any way. Let's see, we got that, and we got a greenie here and a black. These were definitely ganged in a... Looks like the switch contact itself actually contacted a few of these capacitors at once, so it was wired in a way that it would parallel certain devices' capacitance values out of here in order to create the marked value on the front plate that the switch would get you out of the box. But in this case, like I said, the switch is probably really in no condition to be reused. So we're gonna just go through and do a little capacitance test here. Got a meter relatively handy here. The capacitor itself is interesting. It's a G-U-D-E-M-A-N, a Goodman. It's got values of 80, 40, 25, and 10 at 450. And the black is a common negative. Not going to worry about doing any type of a quality job of stripping any insulation off these because it's going to go into the, oh man, it's going to go into a parts recycle bin someplace for electronics components. It's really not even worth thinking about discussing trying to save any of these. If somebody would like to take these and see if they could reform them, give me your address. I'll be glad to send them to you. But it's not going to be an activity that's going to bear any fruit. One more wire here. Okay. All that being said and done here, we've got values of the red's 80 according to this. So we'll take a stab at it. We're gonna think that this guy is going to give us some humor out of the performance, if anything. So we're gonna go here, and then we got a value of 162 microfarads on the red. It's quite the overachiever. The blue is a 40. Blue gives us a 26 microfarad value. The yellow is rated at 25. And in automatic range, the meter says no go. So I am thinking it is grossly short-circuited, and then the green is supposed to be a 10. Green's probably closest of tolerance to any of them at a 13.2. It's 30% above. It's actually kind of funny because it's falling as we speak here. So can't say this is a laboratory grade unit as far as measuring capacitance, but it's a good ballpark meter, and it's quick, and it was fairly inexpensive. So what we can do is also try an ESR meter. That should let us know something else about the condition of these components in here. We go for a 0 on the leads. Okay. We're going to go to automatic. Oh. Doesn't want to go into automatic. Oh. Hold on. We got the meter is not cooperating here. Okay, took a little fiddling. I got my ESR meter to calibrate down to a dead short at 0.003 ohms. We got a black lead. For one of them, our red was at 80 microfarad, so we'll go with that one again. 2.55 ohms, 100 microfarad. Probably should have, there's a 250 volt range on this chart on the ESR meter. It states that a 100 microfarad to 250 should be a 0.8, and it's probably not within specification at all, considering it also measured at 160. So we're not going to think that that's usable. There's the blue lead here. Blue lead says 4.62 ohms. That is a 40 microfarad, 47 microfarad is also supposed to be 0.8, so it's on the high side. Yellow is a 25 microfarad. Yellow says 10.19 ohms. We are leaning towards the side of that is not going to be functional at all. Green was the 10 microfarad. That was the one that tested closest to its proper value out of the bunch. But if you look at the ESR meter, it's not even seeing an equivalent series resistance value on the green lead, the black of the capacitor. So not even worth trying to play with. I would imagine after everything that's leaked out of these things, I mean, just between handling the box and handling the capacitor itself, you can see the large volume of stuff that is creeped out of the box and off the capacitor. It didn't have any type of meltdown because it wasn't subjected to a constant voltage supply to power such a meltdown, but we're gonna kiss these guys goodbye and see what we can come up with for replacements as far as wiring and switching and capacitors. As a tie-in to my first video, episode 002, for my Gigaohm Capacitance Leakage Tester, I am going to humor myself and possibly you by checking the capacitor, one of the capacitors in the Sencore, with the device set connected to the base of Q1. It's the lowest range, well, as far as the lowest range of sensitivity, it's the closest resistance values to 0 ohms that might register, but it will just give a quick test to see what kind of shape they're in, just to kind of show that that's a usable device for trying to test capacitors quick. Just by touching the bare leads with my hands, I get a small indication of continuity on the diode and this, on the LED in this this connection to Q1. And if I do a dead short, it's very bright. This tester seems to be happy if you keep your capacitance under test values, probably under 50 microfarads, and in this case we have a selection of 100s at 63 volts. Granted, the voltage isn't as high, but it's not the voltage that's going to matter as much as the capacitance in this demonstration. And the negative lead is on the end there. The negative lead is my white out of the two, and I'm going to connect that to the negative, to the positive. And if you see, the diode at first is illuminated quite brightly, but now it is going dim. It is about dim to the point where it's barely visible, but it's still lit a little bit. So it's taken the voltage available to it to charge the capacitor, and at this point the capacitors get a small amount of internal resistance or dissipation in series with itself that is causing that. There is a way to kind of prove that it's got some internal dissipation. If I move my connection to Q2, now that capacitor is charged up at a higher voltage at the Q1 base position. At Q2 it does not, the voltage has dropped a little bit, so the charge startup on the capacitor is not going to turn on that transistor base of Q2 for a while. We can either watch it for a while, or you can play along at home and try to rig this up. It's like I said, it was in my video ES-102, and this tester configuration is based on a schematic by a YouTube video produced by Tom Test Kit, and a link to that is in that other video as well. It was a good information, and I just carried a little further, made a few slight modifications to values, and added a third transistor to up the ante on things. But anyhow, we can see it's still not conducting anything yet. And if we go back to Q1, it's still got a small amount of dissipation, probably up in the 50 mega ohm range or so. But it's a good capacitor. It took a charge within a couple of seconds and is displaying itself as a good capacitor. This is one of my Goodmans again. This is the 80, I think I same one as before. This should be the 80402510. And the negative is going to be my white again. Get the LEDs in view there. Probably put it a little better review here. So we're going to go for the 80 and the red first, and this is at the Q1 position. So this is leakage from 50 mega ohms down, probably open circuits about 100 kilo ohms, and will not show any leakage about 100 kilo ohms, I think. This is showing pretty well dead short, so there's internal dissipation or resistance is the internal dissipation is high, the internal resistance is low. This is not the same as the equivalent series resistance, because that is actually an impedance or capacitive reactance measurement. It is not a DC resistance measurement. Capacitors are not normally supposed to conduct DC through them. This test is testing to see if it conducts DC through it. So in this case, it is a failed capacitor. The blue is the 40 microfarad value. Once again, it's indicating is probably a resistive load of under 100 kilo ohms. The yellow is a 25. Once again, it's definitely conducting current that it shouldn't be conducting in DC. And the green is a 10. And that one is also the same. It's basically all indicating is being in a condition of not being functional as a capacitor for blocking DC current. What we can do just for giggles too is I've got a digital voltmeter handy so we can get him into play. See what kind of test that is. We're going to go under 400K because that's where it seems to be what our values of bad behaviors are going to be. I'm going to hold on to the black lead with my hand as I do these. Just probe. No, really the red is not indicating at 400K. But you have to keep one thing in mind, the test voltage on the leads for this might be lower than, well, it's seeing the conductance through my finger. Seeing a resistive value. Not seeing it through the capacitor though, which is odd, but not surprising. We'll check the other ones. See, the yellow is showing 300 kilo ohms. I can't say why the red isn't giving me a value, but it's still, we know it's conducting. We know it's got a leakage issue. The blue, yeah, that one's not giving. And then the green is giving a 800 kilo ohms. So we know that it's not. It's really absolutely no sense at all in trying to revive or do anything with these dynamite sticks. They're basic museum pieces. If somebody, like I said, if somebody feels the need to try to reform them, and or if they want to gut them to stuff for another project or so, give me a message and we can get them off to you. And maybe they'll come in handy for somebody else's project if they want to go through the effort. But I am not going to at this point. It is not going to, something that is not going to bear any fruit, in my opinion. Hi, I'm back. After some disassembly and desoldering, I managed to get all the wires cleaned off of the leads to the switch, and I removed the rotary switch here, and I'm just going to show you here something to look at. This thing is so corroded that it's really not worth saving. It actually ended up getting such corrosion on this one contact that if I take it and bend it in the up position, it does not want to spring back. It's ready. I cleaned it up a bit there, but nothing's going to recover it. Outside of having another full contact to put in here and replacing this brass rivet along with removing the brass rivet and everything, it'd almost be impossible. And then all the corrosion on the silver on there, it's not worth saving. I mean, some of these other ones might be recoverable, but who knows, maybe I can actually think about using those for parts for another switch. But that one's going to be a goner, so I've got replacements on the way. They're not original stock, but they will be functional. And then going back to the switch I need to save, this is it's an oddball. It's a single pole double throw, but the two sets of poles are totally isolated from each other. When the switch is in this position, only these two contacts are connected. When the switch goes to this direction, only these two contacts are connected. What happened was they set this up so the spring will pull, the spring mechanism here that's fastened onto one of the eyelets for the wire exits will pull this whole assembly back and put this in a position where these two leads will route the current through the resistor that was in here, through the capacitor that was used to discharge it, and in this position it was to be held temporarily to disconnect these two leads, and it would put the current from the positive lead through to the capacitor that was selected by the rotary switch. I'm probably going to do something like wire it opposite of that, whereas the capacitor would be connected full time, and if I move the switch position against the spring for a couple of seconds, it would discharge the internal capacitor that was used. That makes a little more sense as far as functionality to me. I mean, this whole thing is basically, it's not going to be a faithful restoration. I can't directly replace those dynamite stick capacitors. Due to all the toxic stuff that was leaking out of there, I'm not going to try to gut them and restuff them. I'm just going to put modern day capacitors on with different connections. Same values as what's placed on the lid though, and that'll just give me something that's more functional and also serviceable, as far as if one capacitor does fail or one bank does fail, you can replace an individual capacitor or a group of capacitors, making up a value instead of having to replace a multiple capacitor unit or go into a restuffed capacitor and try to replace a value in there. So what I'm planning on doing next, I have to salvage this switch. It's to keep its functionality. So this spring was already hooked on there. I removed it, and we're going to bend up the tabs in this guy. I bent one up already. My camera shut off, so we're gonna bend the other ones up. Not the best pair of pliers for it because it doesn't have any serrations on the tip, but it's got a good sharp blade to grab things with. So luckily, with all the corrosion, there's enough metal left. Whoops! There's enough metal left to actually accomplish this. Hopefully, you can bend the back. Man, I'm hoping. Okay. I think I've got it loosened up enough. I'm going to try to maybe a little bit more, if possible. There we go. Oh man. Okay. Here's what we got. We've got what's left of the contacts here. You've got a spring-loaded puppy dog with what's left of the contacts there. And we have a metal alignment plate that the spring was able to pull this through, and then we have its mount with the cover on there. I'm going to probably off camera take a Dremel motor tool and clean all that corrosion up. Treat it with something along with the corrosion that's on the rest of the case here. I've got some cleaning up to do on the whole inside of the lid here. So I'm going to take care of that. In the process of painting, I also have the inside of the cabinet to do still. This one's got all sorts of salt, gunk stuff, and more stuff from the from the existing original capacitors. So what I'm going to hope to do is clean this guy up with some alcohol as good as I can first. some 99% isopropyl. Actually, it looks like the switches still have a good amount of good silver contact to them, which is really good. Doesn't look like there was a lot of wear on the switch itself. It's just the age and whatever those capacitors released on it, God rest their soul, was not kind to this in general. Thankfully none of the plastic cracked in this, and I'm going to hope it stays that way when I go to put it back together. There's no guarantees in this. This is such an oddball switch that I wouldn't be able to replace it easily. I'd have to probably be re-drilling the cover and coming up with a different scheme for the capacitor connections. But up to this point, everything's behaving itself, so you can't ask for more. Hard to tell whether this is plastic or pressed resin composite. Almost looks like a composite from the way it looks porous. I did spray some just regular contact cleaner without any lubricant in it before I disassembled it, just to try to figure out its functionality, because it really wasn't behaving itself as far as having contact when I first started. I did get it to work a little bit, but like I said, judging from the looks of these contacts, they are fairly wear-free, not damaged, no arcing, no overheating or anything, so that's all a good sign. Should provide a service life once you get everything cleaned up and reassembled. And still pulling some dirt off with a Q-tip. We'll get to this little contact as well. This guy is seems to be not much wear in it as well. And even just with some isopropyl alcohol seems to be cleaning up fairly well. I'd imagine if I can get this back together mechanically, there's no reason it shouldn't be functional, barring it something catastrophic happens on my way from bending parts or something. I just want to try to get this as clean as possible when I put it back together, so the less dirt that's enclosed in the switch and the housing in general, it's going to be all cleaned up, repainted with the new non-leaking components inside. So it, like I said, it should give a good service life once it's... And then that's got a spring in it, so we're going to get the spring out of there. Not much dirt in there. I am hoping it's going to be a winner. I'm just going to have some patience and care in reassembling everything. I could put a little anti-corrosive grease on here too when I reassemble it. That might give it some longevity. And probably just go through and clean up any corrosion I can here right now with alcohol anyways, and then a wire wheel for a Dremel will take care of most of the oxidation, and I might just hit the back of that guy one more time. It looks like it's got a little dirt on it. I think that that's probably about as clean as I'm going to get it. I shall put a small amount of Deoxit D5 on all the contacts before I reassemble it, and that should help keep the rest of the corrosion away. But I think for something that's close to 50 years old, you probably can't ask for at least some parts to be intact as they are. If I was going to take a choice of the two switches that were failed due to corrosion, this is definitely the slider switch should be the one that I'd be harder to replace. So it's definitely the rotary switch would definitely be one that I can live with it not surviving over the years. I said it's not the worst thing that can happen, but like I said, this is going to turn into not a faithful restoration of the original item, but a restoration modification, a Resto-Mod, to get it to work how I'd like to. Thank you for viewing my video. If you enjoyed it, please feel free to give it a like. If you would like to be notified when my new videos are released, please subscribe as well. Hope to have you as a return viewer soon.